Hello everybody and welcome back to Absolute Value. Here we are continuing with our series of review for the Regents, particularly for the Algebra 2 Regents. Today in particular we're going to focus on some exponentials and logarithm type stuff and solving those kinds of equations. I know that these are often equations that trip students up, and so I want to make sure that you guys got all the help you can get. And as usual, feel free to ask any questions that you have as I'm going through these in the comments, and I will get back to you as soon as possible with an answer. Anyway, so let's get into this here. Before we do some solving of exponential equations, first we have this problem here expressing exponentials as logarithms. And if we have this right here, p equals 1/2 to the power of q, and we want to express it as a logarithm, we have to kind of remember, okay, log base of some number equals the exponent, which is the same as the base to the power of exponent equaling the number. And just so we don't get confused here with the e, I'm going to just change this to an a really quick because I don't want us to get confused and think that that's the number e. This is the relationship between logarithm form and exponential form. If it's already in exponential form, here we know that p is the number that's by itself, so p goes with n. The base is 1/2, and the exponent is q. So now we just have to turn it into this form up here. So b right here is going to be 1/2, the n, which comes from p, and then the a is q. So now we just have to write that all out. Log base 1/2 of p equal to q, which is choice 3. And this is going to help us to solve some exponential equations as well. If we can turn things from exponential form into log form, that gets rid of some of the variable being in the exponent issues. So let's look at some of these exponential functions here that we will solve, starting with 324. Given that m is not 0, because then we'd have an issue with it dividing by 0. Oh no. We have this equation here, 17 to the power of 1 over m to the power of n equals 17 squared. Just to rewrite this a little bit using our exponent rules, if we have 1 over m to the power of n, that's the same as multiplying those, so n over m equals 17 squared, which means that n over m is equal to 2. Now it's asking us what is n in terms of m. So we want to get n by itself, and in order to do that, multiply by m on both sides. So then we get n equals 2 times m, which is right there. Let's look at the next one. And I know these look really gross. That's why I'm doing them, because I want to make sure these are not the ones you guys are tripping up on. Even though they look hard or tricky, we can do it. We can do it. Nothing's too hard for us. We're solving for x. We want to get x ultimately by itself. So first of all, I see this 2 here on the outside and it's being multiplied, so let's just get rid of it and divide it. Easier. Now we just have 3 to the power of x plus 4 equal to 28. And now at this point we'd say, oh, what number has to be the exponent here in order to get to 28? Well, it's not going to be that nice of a number, but what we can do is we can turn it into log form, and that's what always is recommended. Whenever you have a variable in the exponent, put it into log form. We don't want that variable in an exponent. We want it down on the ground. We use our log rewriting. So this turns into log base 3 of 28 equal to x plus 4. And look at that. The x is not in the exponent anymore. We can very easily get x by itself now. Just subtract 4 from each side, and we end up with log base 3 of 28 minus 4 equals x. And that is choice 1. And this next problem is very similar, but let's just try another one, 327 here. Again, we want to get the stuff with the x by itself as much as possible. So we can divide by 5 here on both sides and just have 2 to the power of 19x equaling to 10. Again, there's a variable in the exponent. Use the log. Use the log to get it out of the exponent and put it into log form, which looks like this. Now we can very easily get x by itself by dividing by 19, and we get choice 2. So I want to do this one now because this one looks a little bit different. The equation looks the same, just different numbers obviously, but the answer choices now have ln in them. So there's going to be one extra step we're going to need to do with these ones in order to make sure we get the right answer. So let's start the same way, divide by 6 on both sides. We'll end up with 2 to the power of x plus 4 equaling 6. Let's put it into log form. Log base 2 of 6 equals x plus 4. Now typically from here we would just say, okay, now subtract 4 and we're done. But there's no log base 2 of 6 over here. Then now what comes into play is this rule right here that says log base a of b is the same as ln of b over ln of a. So this right here, this log base 2 of 6, really just turns into ln of 6 over ln of 2, and then we're still subtracting 4 from both sides, so minus 4, which is answer choice 4. And unfortunately, we cannot combine those 6 over 2. We cannot divide them and say it's ln of 3. That's not how it works, so be careful for that one. Okay, so now I want to look at this problem 332 here, because we've got a 5 in front, and we've got an e as the base. We haven't seen e as the base in a while. That's why earlier I didn't really want to use e, because remember, e is a number. E is like 2.17, something like that. And so e is a number, and you'll see in a second how we're going to use that and how we're going to end up solving for x. All right, so we're going to start out with the same step as before, dividing by 5, because we do want that base with the exponent to be by itself. So we'll end up with this, e to the x plus 2 equals 7 over 5. And now to turn this into log form, log with a base of e of 7 over 5 equals x plus 2. So now we have something a little bit different here. Log base e is the same thing as ln. So this is ln of 7 over 5. And then of course to get the x by itself, we'd have to subtract 2 from both sides. So we would end up with this, which 2 of these look like this answer. But here's the issue here. We don't have log base 5 of 7. If that's what we had, this would be our answer. We have ln of 7 over 5, which is this right here. And then having the minus 2 in front is just kind of a way to trick you a little bit. Or maybe this person just really likes putting the number in front of the ln, but these test makers are a little bit tricky sometimes. But it is option 1. Okay, let's try another one here. This one is telling us that it wants us to the nearest thousandth. So that means we're going to actually find the decimal number for this. So same thing, divide by 87, and we get some gross number. But what we do know, what we've seen in the last one, and maybe a new little trick here, is that ln is kind of the inverse of e, which means if we take the ln to both sides, those cancel each other out and we're just left with the exponent on the left side and on the right side with the ln of that large fraction number. That's kind of what we did back here, but I just showed the steps along the way. But this is something that you can do right away. You can just put ln in front on both sides, cancel out the e, and now you're just left with 0.3x equals this ln number. So then the last thing we're going to do here is divide by 0.3. And this is we need a calculator for this. Good thing they give you one. So we're going to do this fraction, and then the ln of that, and then divide by 0.3. And my calculator is telling me 14.066. Look, that's an answer choice right here, for number 4. So there you go, not too bad. All right, so let's jump down to number 335 here, and we want to find which expression is not a solution to this equation. So basically, I'm going to look at the different ways that we could rewrite this, and that is, well, first of all, if we want to rewrite this in log form just as it is, this would be log base 2 of the square root of 10 equal to t. And look, that is an answer choice, so when it's saying not a solution, this one won't be it. And then something interesting that we have here with our log rules is that, well, first of all, the square root is also an exponent of 1/2, which that exponent of 1/2 we can put in front. So we can actually get this to be 1/2 log base 2 of 10, which is this right here. So yes, that's allowed. So then the next one is a little bit tricky of which one it's going to be, but really a good way to think about it and look at this is, look, the number after the log for all of these is a 10. Why would it all of a sudden switch to a 4? It wouldn't. I mean, this option 4 is going to be our answer, but I'll tell you why right now. So this right here, this log base 4 of 10, this is the same thing as log base 2 of 10 over log base 2 of 4, which log base 2 of 4, if you were to put that in a calculator, basically what log base 2 of 4 is asking is what power of 2 gives you 4, which is 2. So it would be log base 2 of 10 divided by 2, which is the same as this previous one. So this one is also a potential solution. Okay, let's do a few more here. Let's do this next one, because this one involves a little bit more variables and stuff. We have this equation a to the power of x plus 1 equals the third root of a squared. First of all, when I have these roots and things like, and a power as well, I like to rewrite my equations here just because it helps us to visualize things a little bit better. And remember that the cube root of a squared is the same as a to the power of 2/3. So now this really helps us because we know a to the power of x plus 1 is equal to a to the power of 2/3. So that means x plus 1 must be equal to 2/3, which means x is going to be negative 1/3 once we subtract 1. So we're going to stop there. We've done a ton of problems here solving exponential equations. Hopefully that was helpful to you. If it was, feel free to leave a like or a comment or leave any questions in the comments as well, and subscribe to see any other content that I'm posting here. I said this in a geometry video as well, but this applies for Algebra 2. Math builds on itself. So if there are some more Algebra 1 concepts that you're still struggling with, those could appear in your Algebra 2 test. So go back and check out the Algebra 1 videos too. Why not? I will see you guys in the next video, and as always, happy studying!